Hello everyone. In this section we are going to learn about what we call the fundamental theorem of calculus. So we're going to do fundamental theorem of calculus. Fundamental theorem of calculus. In short, we're gonna call this FTC, Fundamental Theorem of Calculus, FTC. So in this Stuart book, this is section 5.3, and in the Thomas book, this is section 5.4. So it doesn't matter, just pick any book. The theories are the same, so you can learn from any book you like. Okay, so before we go further, I want to give you one simple result that we're gonna use later. We can do more problems after we do integration by parts. Okay, so the idea is coming from this one. So let's say you have a graph. It's like I'm gonna call it like that, something like that, and then this graph has an area. So right, this graph has an area. So so what we're trying to do, we try to find a kind of rectangle which has the exact same area. Okay, so this we say y equal fx, then this has area, but we try to find a rectangle which has the exact same area. So maybe something like this. If you look at this rectangle has the exact same area as the area below the curve. So okay, and so that's the idea. Okay, and then this height, this rectangle has a height. So that height is what we call the average value. So average value of the function. Okay, so there's a formula. So the average value, or called the mean value. Mean means average. Mean value, average value, or the mean value. Mean value. So we call it AVG of the function f, which is simply 1 over b minus a, the integral a to b fx dx. Okay, so we know that that's the area. So right, area under the curve. So what we do, we're gonna find the area under the curve and divide it by the length. Okay, that's the length, b minus a length, which is b minus a. So we find the area and divide, and that's what we call the average value of the function. Okay, we can do more problems later, and then if you see that to find the average value of the function, this is the formula you have to use. Okay, so I'm going to put that there. So now let's try to learn a little bit more about the fundamental theorem of calculus. There are two versions. Okay, so part 1. This is part 1. So so let's look at the same idea that we talked about earlier. So we have a graph, and then so I'm going to call this y equal fx, and then what we're trying to do, we're going to talk about the antiderivative. Okay, antiderivative of this function, and we just talked about that in the previous section. This antiderivative going to give you the area, right? So that the area function, so that's the area until x. Okay, so actually it would be better if I erase this part, because we try to find the area up to x. So yeah, so I'm going to take this out. So it's much useful at this time. Okay, so so we have the curve, and then we try to find the area up to the x value. Up to the x value. Okay, So and that area up to the x value is the antiderivative. We normally call it is big F. So that is the integral from whatever the starting value all the way up to x. So that's the area, which is the integral up to x. Okay, so it is fx, which is the integral you integrate from a all the way up to x fx. Please read this section after you read in the previous section, okay, because there we discuss something related to this one. Okay, so what you want to understand, the antiderivative gonna give you the area below the curve. So now what we're gonna do, let's try to find. So let's start with x, and I'm going to go slightly away from that x. So I'm going to say I'm going to go slightly away from that x. Okay, so the new value I'm going to call x plus h. So that means you move only h away from that. So that means it's going to create an extra area. You see that? It's going to create an extra area. So what is that area? That additional area is the area between the two values. That means the area at x plus h minus the area at fx. That is the red area between the two. But now we can and then you can see that this area is approximately equal to what? Can you give me a value for that? What this area is approximately equal to? It's approximately equal to the area of this rectangle, the one I just draw. Okay, so what is this value? What is the area of this rectangle? The height is fx. You see, height is fx, and the width is h. So this is simply h times fx. That's the height times width. Width is h, height is fx. So that's the height times width. So this is very clear. The gap in the area is simply height times the function value at x. Now what I'm going to do, I'm going to do some algebra. I'm going to divide both sides by h. I'm going to divide both sides by h. Then you get this is approximately equal to fx. Now what I'm trying to do, I'm going to take the limit. Okay, so take the limit when h goes to 0. So when you take the limit when h goes to 0, fx plus h minus fx over h, what will happen? So then this simply becomes the value at fx, because it's getting smaller and smaller and smaller. So then it's gonna be equal to fx, and on the left side, what do you see here? This is the derivative of the uppercase f. You see, because this is what you learn from Calc 1. Okay, from Calc 1 we know that that's the derivative of the function. So this is from Calc 1. So you can see that if you integrate the antiderivative, you get the function back. Okay, so this is what we call the fundamental theorem of calculus part 1. If you take the derivative of the antiderivative, you get the function back. Okay, so it's like this is very short, so that's a proof of that. Okay, so let's write this as a result. So I'm going to call it a theorem. So theorem. So it is a fundamental theorem of calculus, part 1. Part 1. So if f is continuous, if f is continuous on AB, so you need an interval on AB, then the fx, the antiderivative fx from a to x, ft dt. Remember that you have to be careful, don't use the same letter here. because since we have x as a limit, don't use x inside, use something else. So we use t. Okay, so what it says that if f is continuous, then this is also continuous, is continuous. Okay, antiderivative is also continuous on AB and differentiable. Then you can take the derivative, differentiable on the open interval AB. Okay, so it is continuous on the closed interval. It is on the closed interval, continuous on the closed interval, differentiable on the open interval. Okay, and you can say and the derivative of f prime, or derivative of f, which is f prime, is simply given by the derivative of the integral a to x ft dt. So it is simply fx. So you simply replace t by x. Okay, you simply replace, put x in there. So it's going to give you the function. Okay, so that is the fundamental theorem of calculus part 1. So what it says that you first integrate and then take the derivative, you get the function back. You get the function back. Okay, that's the derivative. Okay, so so you can see there's a very simple result, and then let's look at some examples. So examples. So let's say use the fundamental theorem of calculus. Fundamental theorem of calculus to find dy by dx, or the derivative dy by dx if let's do a couple of examples. Let's do y equal, how about this one, a some number 2x t3 plus 1 dt. That's the first one. You can see that this is in the right format, and you also know that the function f is continuous. So so what we notice that this is a nice continuous function. CDS means continuous. So that means according to the theory, so what's going to happen, this is simply, what you want to do, you replace the function by and you can see that in the bottom is in the right format. It has to be a to x, so it is a to x, so everything looks good. So you simply want to replace t by x inside. So that means your answer is simply going to be x3 plus 1, and that's it. You replace the t by x. Very simple. Okay, so let's do another example. How about this? How about y equal, let's say x to 5 3t sine t dt. Any idea? Is this in the right format? Is this a to x? You notice that it's not a to x, it is x to a. So that means you have to switch the order. So we can use one of the results we discussed in the previous section. We know that if you switch the order, it's going to give a negative sign. So that's the first thing we do. So actually I want to do something. I forgot. Yeah, I'm going to erase something in my previous slide, because we cannot just write it like that, because we are talking about the derivative. So so I'm going to erase this part because that's not equal. So I have to write it like this. So this is going to give you the derivative dy by dx, dy by dx in this case. You can see there is a function of x. Once you take the integral, it's going to be a function of x. So it is now you write x3 x3 plus 1. So what you had before is wrong. They are not equal. So the same thing. First, what I'm going to do, I'm going to change the okay, now I'm going to go to the second question. Okay, so please make the correction here. You can say y equal x3 plus 1. That's wrong. Once you take the derivative, you're going to get that. Okay, so it has to be like that. Actually, I would try to write a little bit more there. I'm gonna go back to the previous problem and try to kind of make a little correction there, little addition there. So then it's gonna be d by dx, the integral a to x t3 plus 1 dt. Now you can see this is equals to, so here the fundamental theorem of calculus, FTC. From that you're gonna get tx3 plus 1. So this is the proper way to write it. Okay, so make sure that you write it like that. Otherwise it can give a wrong idea. Sometimes we know but we write something else, so you have to be very careful with that. Okay, so here, so first I'm gonna get in the right format first. So it is the negative. I'm gonna write phi to x 3t sin t dt. Okay, now we can see it's in the right format. So now we can find the derivative. So after that we can say, okay, dy by dx, not dy by dt. Okay, it's a function of x. Good, because after you plug in those x and phi, it's become a function of x. Okay, now again, so it's a d by dx negative phi to x 3t sin t dt. Now what we can do, this is a derivative. You can pull the negative sign out. So take the negative sign out, and then we have d by dx, the integral from phi to x 3t sin t dt. So only thing I did was I just pulled the negative sign out. Now we can use the fundamental theorem of calculus. According to that, it's in the right format, and this is a nice continuous function. So that means you can just plug in the value there because it's differentiable. So you can plug in the value there. So it's a negative. You replace t by x. So it's a 3x sin x. Okay, 3x sin x. So is that clear? Yeah. First you need to switch the order to get to the right format, and then you plug in. Excellent. Okay, so let's do one other example. Number 3. How about this one? Y equal something to x squared cosine t dt. What do you notice? Do you see that it is not of a to x? So it's not of a to x. See, it's something. So that means it is not in the right format. So that means you have to bring it to the right format. So what are you gonna do? We're gonna say take u equal x squared. So that is the starting point. Whatever the function you have, you're gonna pick this as u. Okay, you're gonna pick this as u. So if you do that, then what's gonna happen? You can write your integral as 1 to u cosine t dt. Now you can see that it's in the right format. Okay, so you have a new variable u. That's fine. Just a single variable. So what are you gonna do now? We can use the chain rule. So take u equal x squared and use chain rule. Okay, so we can use the chain rule. So what we need dy by dx. That's what we are looking for. Okay, that's what we are looking for. So but you can see that from the chain rule you can write this one as dy by du and then du times dx. That's what you learn in calc 1. Okay, chain rule. So let's plug in. So dy by du Now you can do it. Okay, so so what's gonna happen, this is the d by du, the integral. So but u, y is what, it is 1 to u cosine t dt, that's the first part, and then du by dx. Okay, so that's that part going there. So now we can plug in. Okay, we can simply substitute for these. So what's gonna happen? So here we can use the fundamental theorem calculus for this part, FTC. So from the fundamental theorem calculus, you can see that this is the u and that's the u. So those two match. So these two should match to use the fundamental theorem calculus. So they match. So that means your answer gonna be now, you can simply replace the t by u. So right, so it's become cosine u. Okay, I hope that part is clear. Cosine u. Du by du, that means you take the derivative of u with respect to x. So what do you get? 2x. So there is 2x. So now what we can do, we can replace u by x squared. So that means it's going to be cosine x squared times 2x. Be careful, this is x squared is inside, 2x is outside, so you better write it as 2x cosine x squared in the final answer. Okay, so when you just write cosine x squared, you don't need the parentheses, you can just leave it like that. Okay, so we always need to write the best way possible, because it's going to make it very, very clear. Okay, so this is clear now. So if you discuss this again, so what happened is 1 to x squared. X squared is not just x. So what we can do, we're going to use a substitution here. So we're going to call that whatever the function as u. So u equal x squared in this case. That means your integral become 1 to u. And then what you want to do, you have to use the chain rule. Okay, so when you use the chain rule, it is dy by dx equal dy by du times du by dx. So the first one you're going to replace by the fundamental theorem calculus, and the second one du by dx you can easily find. So the first part simply becomes cosine u, the second part becomes 2x, and then you're going to plug in u back. That's the u function, and then in the final answer you can switch the two just to make it clear, just to avoid confusion. Okay, good. So let's do one last problem from this one. So how about this one? Y equal let's say 1 plus 3x squared to some number. Okay, you want to only make sure that that is continuous, that's the only part. So 2 plus e to the t dt. See where the t goes, where the x goes. Okay, so so the answer, this is very similar to the previous problem. You're gonna pick u equal 1 plus 3x squared, then your integral becomes u to 4 1 over 2 plus e t dt, and also you can switch the order to bring it to the right form. So it is 1 over 2 plus e t dt. Good, now we have everything we need. So dy by dx, which is dy by du, du by dx. First part we can use fundamental theorem calculus. So if I do that, I can pull the negative sign out. D by du for u 1 over 2 plus et dt. That's the first one. The second one is the derivative. So if you take the derivative, you're gonna get 6x. Now from the fundamental theorem calculus, you're gonna simply replace the function by u. So that means 1 over 2 plus eu times 6x. Now you put the u back. Okay, so if you put the u back and simplify, you end up getting negative. 6x goes to the top, and the 2 plus e, what is u? U equal 1 plus 3x squared. So that's the final answer. Okay, you can see that that's not that long, but we want to understand just a few things, and also please understand how we write the final answer. For example, you might need to like put the negative sign in front and things like that. Also remember, like, when you try to put answer in WebDesign, please try to follow the command there, because they're going to give you like little extra information. Sometimes, like, when you add a C, they expect that you put the capital C instead of the simple C. So you have to be careful with that, because this is just like a system, it doesn't have any brain. It just try to match your answer with the answer bank, the solution bank. So they have like a solution set, they match with that, so they can't even understand the simple thing. If you make a simple change, if you put extra dot, so you have to be careful. So but it will be clear, after use like several times, it will be very, very clear how to do it. So okay, good. So yeah, so that's about the first part. So let's go to the second part of the fundamental theorem of calculus. Actually, we already know that. We used that in the previous section. So I'm just gonna write it now, okay, and do some problems from there. So so 2. So I'm gonna write like that. So fundamental theorem of calculus, part 2. So I'm just gonna give you the theorem, because we already know this one actually. So so part 2. So what is that? So let's say if f is continuous, CDS, okay, it's continuous over AB, and this is interesting part, f is any antiderivative okay. So remember, it's any antiderivative. This is which one. So that means you can even ignore the plus c in this situation. This is any. Okay, you don't want plus c here. You know that when you integrate, you're going to add a plus c, so you don't want to do that here anymore, because it says that any antiderivative of f on AB, then it says that the integral from a to b fx dx is simply if you plug in the top value minus you plug in the bottom value. That is what we call the fundamental theorem of calculus, part 2. So what is it? Pick any antiderivative and substitute the first value minus substitute, okay, I'm sorry, and then minus substitute the second value, fb minus fa. Now actually we can use some notations here. This one we sometimes write it like this. We can say fx, we draw a line, vertical bar, we put ba to mean that that's a notation. When you do that, it means you substitute the top value minus substitute the second value. Sometimes we even write it like this. We put like a complete bracket around like that and put ba. So it doesn't really matter. So just make sure that you use same one every time. Only thing you need to understand, this is just a notation. Okay? It's just a notation. Okay, so this is the fundamental theorem of calculus part 2. Okay, this is very, very useful for applications. So you pick any antiderivative and then substitute the top value and then minus substitute the second value. Okay, so that's it. And we discussed why this is, because what we try to do in the previous discussion, you know that the this if you look at the definite integral, that's an area. So that means we need to find the area between a and b only. So that means we find the area up to all the way up to, so if we only need this area, so what we do, we find all the way area all the way up to b, and then subtract the area up to a, so that you just get only this part, because otherwise there are some extra part. If you just say b, you can calculate all the way to b, so it's starting from negative infinity. So we don't need that, so that's why we only cut the value between a and b. Okay, so how to cut it? You go for the larger value and subtract the smaller value. It's always value from the right minus value from the left. Okay, yeah, that is the right value, that's the left value. Okay, so let's try to do some examples. Okay, so let's say find the definite integrals. Definite integrals. Okay, find the definite integrals. Good. Okay, so, and then after that I'm going to do like one area problem also, just to make sure that we understand the idea. Okay, so find the definite integral. So the first one, let's say 0 to pi cosine x dx. 0 to pi cosine x dx. So what is the, so we just need an antiderivative. What's the antiderivative of cosine x? Just one. This is a cosine, so the antiderivative is sine x, so right? Sine x. This comes from the table. And then what you will do? You evaluate at pi and 0. Okay, what does that mean? You're going to plug in the first value minus top value minus plug in the bottom value. So what is sine pi? Sine pi is 0 minus sine 0 is 0, so you get 0. So answer is 0. Okay, so let's do another one. Let's say negative pi over 4 to 0 secant x tan x dx. Any idea what is the what function has the derivative as secant tan? What function has the derivative as secant tan? And if you look at the table that I gave you last time, you can see that the secant has the derivative secant tan. So that means this is the antiderivative is simply secant x. Okay, secant x. What do? You plug in the values 0 and negative pi over 4. So it is so it is secant 0 minus secant negative pi over 4. So and then what happened? Secant 0 is 1 over cosine 0. Cosine 0 is 1 minus this is also 1 over cosine negative pi over 4, but we know that the cosine is an even function, so here you get 1. Cosine is an even function, so that means you can ignore the negative sign because it's an even function. If it's an odd function, that sign comes out. So pi over 4, what is pi over 4? Pi over 4 is 1 over square root 2, so that means when you sit upside down, it's going to be square root 2. Okay, that's square root 2. Okay, let's do a few more examples. I hope this is clear. Okay, and then so let's do a few more. C. How about this one? 1 2 4 3/2 square root x minus 4 over x squared dx. Okay, so what is the antiderivative of that? So it is 3/2. You have to add 3/2 and then divide by that. So it is, if you add this 3/2, when you divide means you multiply by 2/3 minus how we do this. So this is 4, and then when you take this to the top is x to the -2, so you add 1, it's become -1 divided by -1. Okay, so that's what you get, and then you have to evaluate this at 4 and 1. When you have more, it's you better be put a parenthesis around just to make sure that, and then we can simplify this a little bit. So you can see you get x 3/2 plus 4 of x, and evaluate at 4 and 1. Okay, so let's plug in 4. So it's a 4 3/2 plus 4 over 4 minus, we plug in 1, so 1 3/2 plus 4 over 1. How much? 4 3/2. When you have 4 3/2, go half means the square root, so find the square root first and then you cube it. If you take the square root of 4, that's 2. When you cube it, you get 8, so it's become 8. And then here this is 1, and then minus this is 1 plus 4. So how much you get? You get 9 minus 5, that means 4. So the answer is 4. Okay, another one. So it is 0 1 dx over x plus 1. So what's gonna happen? So what is the antiderivative of 1 over x? This is the natural log, so right, that's the natural log x plus 1, because we know that when you take the derivative of natural log of x plus 1, you get 1 over x plus 1, so you can go backward. Okay, so and then again you can evaluate this at some people like write it like that, like with corners, but that's okay, so whatever you get used to. Okay, so like that, and then let's plug in the values. So you're gonna say ln, we plug in 1, so it becomes 2 minus, when you plug in 0 it becomes ln 1, but ln 1 is 0, so you get ln 2 as the answer. Maybe just one more. 0 1 dx over x squared plus 1. This is one of the formula in the table. When you have 1 over a squared plus x squared, which is 1 over a tan inverse x over a, so I know that here a is 1, so that means this is simply tan inverse x. Some people write this arctan, it's the same thing, the arctan or tan inverse. Okay. So it is 1 and 0, so it is tan inverse 1 minus tan inverse 0. How much tan inverse 0? With tan 0 is 0, so tan inverse 0 has to be 0. It is because tan 0 equals 0. How much tan inverse 1? For what value you get 1? For the value pi over 4 you get 1. So it's pi over 4. Minus 0, so it's pi over 4. Okay, but this is pi over 4. Okay, good. So this can help you for the next homework from fundamental theorem of calculus. Okay, so this is pretty much what I'm gonna do, but I would like to discuss a maybe one application problem. Yeah, I'm gonna do like one area problem and some formula that gonna help you for some other classes. So let's try it. So it is called the net change theorem. It's a theorem. It's called the net change theorem. Net change theorem. So what it says, so it says that the net change or the total change, okay, the net change of a differentiable function net change of a differentiable function f is the integral of its derivative. We know that because if you integrate the derivative, you should get the function back. Is that right? So that means your net change is fb minus fa. That's the net change of the function. What is the total change? It is simply the integral from a to b f prime x dx. Is that right? F prime x dx. If you integrate the derivative, you should get the function back. So that's like kind of simple idea. So you integrate the rate, then you get the net change. You integrate the rate, so that's the rate of f, okay, the average value of the rate. So for example, so if you know the velocity, you can find the displacement. That's a kind of good example. If you know the velocity, you can find that displacement. Okay. So let's write an example for that. So if Vt is the velocity, then the displacement, between two times t2 to t1 is s. We normally use the s for displacement. It is s t2 minus st1, which is the derivative, which is integral from t1 to t2, the slope or the derivative of the s function, but we know that is the velocity. So that means we simply integrate the velocity of the function. Okay, so that means if you know the velocity, if you integrate it, you're gonna get the displacement. So that's the displacement. Okay, so that's one example. And also you can slightly modify this one. If you need to find the total distance traveled, So how to get the total distance traveled? So for that we use the speed. We use the speed instead. Okay, we use the speed. What the speed means? That is the absolute value of the velocity. Okay, use absolute value of the velocity. So that means the total distance traveled is simply the integral from t1 to t2, but the velocity function is the absolute value from absolute of the speed. So you have to be careful with that. So that's the speed now. Okay, speed means simply the absolute value of the velocity. So this is one such application, and these kind of applications are useful in some other courses as well. For example, in chemistry, if you know the rate of change of a chemical reaction, and if you want to find the total reaction, you just integrate the rate. So once you integrate the rate, you end up getting the you end up getting the total reaction or the net change. Good. Good. So let's try to do something. How about okay. So so let's try to do a one practical problem here. So how about this one? So in this example, the velocity of a rock at any time t is given by Vt equal 160 minus 32t feet per second. Okay, so the question, let's ask two questions. Find the displacement during the time period from 0 to 8. Okay, 0 to 8, and then do the first one. Find the total distance traveled. Find the total distance traveled. Total distance is a distance, so that means you need the speed. So for the first part, that's easy. It is asking the displacement. That means you just take the integral of the derivative, right? Displacement derivative means the velocity, so you just integrate the velocity. So let's do that. So the answer, so you can say the displacement okay, so the displacement is the integral displacement is the integral from 0 to 8 the velocity, right? If you integrate the velocity, you get the displacement. So it's from 0 to 8 the function was 160 minus 32t dt. So this is, if you integrate this one, you're going to get 160t minus, what's the integral of 32t? So it is 32t squared over 2, that means 16t squared. Now what we can do, we can evaluate at 8 and 0. So if you plug in 8, you're going to get 160 times 8 minus 16 times 64. You simplify, you get 256 feet. Okay, 266 feet. So that's part A. What about part B? In part B, what will happen, you can see when it passed 5th second, so the velocity is going to be negative. So right, but if you look at the graph, it will be very clear. So what's the velocity graph? So that's the velocity, and this is the time. Star v 160 is with a negative slope. It's going to go down, and that's 8. What number when you get 0? So you can see it is 160 minus 32t equal to 0. So that means t equal 160 divided by 32, which is 5. So at 5 seconds, velocity gonna be 0. That means you can change the signs. That means you have to split the integral between the two. If you just integrate, you don't get the actual distance, because distance means you have to add them all the way. Okay, so that means you have a different integral right now. You have to take the absolute value. Okay, so the total distance. So you see that the velocity becomes 0 here. Okay, at this point the velocity is 0. So this is 160. You have to change, because you can change the sign. Total distance is simply the it's the same integral 0 to 8, but the absolute value. Since absolute value, if it is all the way positive, no problem, just integrate. But here is change the signs. That means you can split the integral between 0 to 5. One integral, and then 5 to 8 another integral. Good. So from 0 to 5 it is positive, so that means it is simply 0 to 5, 160 minus 32t. But from 5 to 8 it is negative, so that means you have to multiply by another negative sign to make it positive. That means you can switch the order. So it's 32t minus 160. So that's what happened. dt. Okay, now we're going to integrate this one. So here it is 160t minus 16 t squared. This you can evaluate at 5 and 0, plus here it is 16t squared minus 160t. You can evaluate this one at 8 and 5. And if you do the simple all the calculations, you're gonna get 400 minus 400 plus 144. You end up getting 544 feet. That's the total distance traveled. Total distance traveled. Okay, so this is like a situation like this. So let's say you throw a stone up, so it's gonna go up and gonna come back, so like that. So that's the kind of situation. So this is t equal 5. You throw this at 160 feet per second. Okay, so it's gonna go. So the total distance, you would add the two. So this can be 144. This can be 400. So total is 544. Okay, so this is the kind of application how you can use it. So so what we did was we used the we split the integral when you find the total distance, and for the displacement you don't want to do that, you can just integrate this one. So there are two different answers in this situation. Okay, but displacement is completely different from the total distance traveled. Okay, let's do one more application of this one. The other aspect is total area. Okay, total area. So that's the last one. Total area. We discussed this one before also. So let's do an example like that. Find the total area of one period of the cosine graph y equal cosine x. Okay, one period of cosine x. So it is like, so let's look at the graph. So you can see the cosine graph looks like that: 0, pi, 2 pi. So this is a cosine graph, but you can see that one is a positive area, one is a negative area. Then we have to split the integral between the two. Okay, so so the total area is what do you want to do? You need the absolute value in these two situations. Okay? So so it is the 0 to 2 pi absolute value of the cosine x dx. That means you have, because you know that there is sign change, that we have to split the function in those two situations. So we have 0 to pi, no problem, it is positive, plus, and you can see from pi to 2 pi it is negative, so you have to put the negative cosine x dx. Okay, why? Because in this part it is negative, so you have to put extra negative sign to make it positive. Okay, now we just finished the integral. So antiderivative is it's a cosine, it is sine x, so you can integrate at pi 0 and then minus again so antiderivative is sine x, antiderivative is sine x, the negative sign coming here, and then again 2 pi and pi. Actually we made a mistake here, so I just draw the wrong one. So I mean, actually what I was doing, actually I wanted to do the sine graph. So let's change the problem now a little bit. So what we have is, yeah, it's completely different, so I might need to change it completely. So let's do it like this. Yeah, I'm gonna slightly modify it. So let's have the same graph, and then I'm gonna change the function here. So let's say, yeah, I'm sorry for that. So what we have here is, I was thinking something and doing something else. Okay, so I'm gonna erase this one. I'm gonna change this. Let's change this. Okay, so now we can slightly modify the problem. So we have, what we have is okay, so find the total area of one period of sine x. Let's do sine x. Let's do sine x. Okay, so let's say sine x. Sine x. So this is the sine graph now. Graph is right, graph is sine, but I just draw the cosine. I was thinking two things at the same time and then switched the order. Sorry. So what happened now, it is again sin x, and then so this is sin x, no problem, sin is positive here, and then this is negative, so it's a negative sin x. Good. Sine means what? The integral of sine means negative cosine, and we have a negative sign. With the negative cosine become plus or positive cosine here. Good. Okay, now we can plug in the values. So we plug in the values, is negative cosine pi minus cosine 0, that's from the first one, plus cosine 2 pi minus cosine pi, that's from the second one. Just plug in the values. Cosine pi is negative 1, cosine 0 is 1, plus cosine 2 pi is 1, cosine pi is negative 1. So if you simplify, what do you get? You're gonna get 2 plus 2, which is equal 4. So the total area is 4 units. Okay, total area is 4 units. Okay, so this is the end of definite integrals, okay, along with some applications. Good. So I'm just gonna give you just one example, but I will not do it. I will just give you the idea. So for example, I'm gonna give this an exercise. Find the total area. Find the total area enclosed by the curve y equal, let's say, x3 minus x squared minus 2x on the interval -1 to 2. So find the total area enclosed by the curve y equal x3 minus x squared minus 2x from -1 to 2. So if you get a question like that, what you want to do first is you want to figure out what is the shape of the graph. So this is something like, these kind of graphs you draw in pre-calculus. So the first thing that you need to do is you wanna know what are the zeros. So for that, complete factor, and you can see that if you factor this, you're gonna get x. If you factor x first, and then you're gonna get x squared minus x minus 2, which has x minus 2 and x plus 1. Okay, those are the factors. That means there are 3 zeros, 0, 2 and -1. So if you look at the graph, so I'm going to draw the graph here. If you look at the graph, it looks like that. So we have -1 as 1 0, and then we have 0, and then we have 2. Those are the 3 zeros. And if you look at the graph, so it's going to go like that, and go like this, go like that. So that's the shape of the graph. So what I'm asking this total area. So what you want to do, you want to split the integral into 2 parts, one going from -1 to 0, the other one going from 0 to 2. Okay, other one going from 0 to 2. So split the integral and integrate them separately. You want to make sure that you use the absolute values here. When you take the absolute value, if it's a negative part, so is the side. Okay, so I will include this problem to a written homework problem. So the written homework, I'm gonna post Friday. So every week on the Friday there will be a written homework. So there will be like about 2 questions from each section that we covered, just to make sure that you know how to write problems and it can help you for the exams, because in the exams those are written work, those are not given in web design, so those are written work. So I want to make sure that you understand how to do it. Okay, so this question will be included in the written homework. Okay, so this is the end of the section for fundamental theorem of calculus. Okay, so thank you so much.